everyone, hello, how are you today? Today we will learn about optimization problem. But before that, if you like my video, please like, subscribe, and then if you have any suggestion for my video, please comment in the YouTube below. Okay everyone, without further ado, so enjoy my video.
In this section, we solve apply maximum minimum problems in which the function is not given directly. When we face such a problem, we are required to first find the appropriate function to be maximized or minimized. The following step will be helpful for solving this problem. The first, to determine the quantity to be maximized or minimized and label it with a letter. In our book, they say it's M. And then assign letter for other quantity, possibly with the help of figure. And then the third, express M in terms of some other variables. And then the fourth, use the data in problem to write M as a function of one variable x, say M equal mx. 5. Find the domain of the function mx. 6. Find the first maximum or minimum value of mx with help of the first derivative. Such problem where we look for the best value are called optimization problem. So everyone, when you find the optimization problem, you should find the maximum and the minimum value with help with the first derivative. So enjoy my example.
Example, a man has 40 meters fencing that he plans to use the enclose a rectangular garden plot that will maximize the area. So they told us what the maximize area. Okay, now we will solve. Since this one is rectangular, the rectangular shape is like this. This one is rectangular. Let's say this one X, this one Y. Okay, everyone. So what's the man has 40-meter fencing. Fencing is memagari. So the perimeter is 2x plus 2y, because they talk 40 meters, so it should be 40 meters. So we divided this all divided by 2, it should be x plus y equal 20 meters. Okay. Now we will find the area. How to find the area? Area is equal x times y, everyone. So you can using this one to be y equal 20 minus x. So you can substitute y from here. So x times 20 minus x is equal 20x minus x squared, everyone. So do you understand from here? Because it's impossible if x less than 0. So x it should be more than 0 and y is more than 0. Okay. Because we want to maximize is using critical point. So from here you need to derivative this one to be equal 0. The first derivative of a is 20 minus 2x equal 0. So you will get x equal 10. Okay, everyone, you get x equal 10. So this one is, yes, correct. This one is critical point. You get critical point. To investigate this critical point, we can calculate the second derivative. The second derivative from here is minus 2. Minus 2 is that the meaning is less than 0. So this one is imply of local maximum. Implies that A has a local maximum x equal 10. So everyone, you need to doing like this question is step by step. The first you need to what they ask first. After that you solve this first. If they talk about maximize or minimize, you need to make the critical point. The critical point is that the meaning equal 0. When you first derivative, you will get the x and then CP, and then you need to find the second derivative implies or not implies. Because this one implies, so the A is correct, x equal 10. Okay everyone, from here the second derivative x is less than 0 for all value of x in 0, 20. So we know maximum value, max value x is equal 10. And then we already know is y equal 20 minus x. From where? This one from here. Okay, so you need to substitute the x from here. So 20 minus 10 is equal 10. Okay, you get the x and you get the y. So you need to find the A. The area is equal x times y. X is 10 meters times 10 meters. So it will be 100 meters squared. Okay, everyone. I hope you understand what I'm explaining today. So, okay, now we will going to another example. Okay, find two positive number x and y such that their sum is 15. So, such that is 15. Answer: x plus y is equal 15. And x squared plus 5y is as small as possible. So let r equal x squared plus 5y. So there is a variable x and this is variable y. So you can substitute from here. So this one it will be y equal 15 minus x. Substitute from here x squared times 15 minus x. So it will be x squared minus 5x plus 75. Okay, so you need to find the derivative about this one. The derivative about this one is 2x minus 5 is equal 0. So you will get x equal 5/2, everyone. Because now we're talking about from here. So you can continue this one to substitute from here. Y equal 15 minus 5/2 is equal 15 times 2, 30, 25/2. Okay, so you can using application to implies to know is it exactly correct or no. The second derivative of r is 2 is that the meaning more than 0. Okay, for all value of x in 0.9. Okay, everyone. The second derivative of r is implies that x equal 5/2 is the minimum. Okay, everyone, maybe you're curious why we should using the second derivative. This one is proving if this x is the minimum or the smallest point. So if you want to not using this one, it's okay actually, but maybe it's little bit dangerous if you're not to proving this one. If this one is correct, implies you can continue to this one. Okay, everyone, now we will talk to another example. Okay, everyone, another example. A manufacturer has an order to make cylindrical cans with a volume of 500 centimeter cube. The volume of cylindrical is PR square H equal, the volume is 500. So you need to change to be H equal 500 over VR square. Okay, they told us find the radius of the cans that will minimize the cost of the metal the production. you can imagine if the cylindrical want to have minimize the cost, is that the meaning they have minimized the surface area too. So the surface area is A equal, because this one not 2 from X, but this is A to R is equal to VR square plus 2PRH. Okay, everyone. So you can substitute H to be here. So 2PR square time plus 2PR times 500 over VR square. So you can cancel PR. So this one is R left. So 2PR square plus 1000 over R. Because they tell us about minimize, so you need to make this one to be first derivative. The first derivative of AR is 4PR minus 1 minus 1000 over R square, everyone. Now, because we already know this must be equal 0, this one is must be equal 0, so you can sum the same denominator R square 4 PR power 3 minus 250 equal 0. So this one it should be 4 PR power 3 minus 250 equals 0, and then divided the left side and the right side to be 4. So the result will be VR power 3 is equal to 150. So R power 3 is equal to 150 over V. So the R is square root of 250 over V is what? Is this one. Or we can prove this one to be the second derivative is implies or not. The second derivative of the area is 4P 4P plus 2000 of R power 3. So this one is implies 2R equal 200 over P cube, and A gets the smallest or minimum cost for minimum value or minimum cost when R equal square root of 3 250 over 4 over P, I mean. So that's for today. No, we still have another equation. Find the area of the largest rectangle that has two vertex on the x-axis and another two above and the axis on the parabola y equal 3 minus x squared. Rectangle is the shape is like this one. Rectangle is like this. Okay, there is x and there is y. Everyone agree? Yes, you must be agree like this one. They told us two vertex on the axis and another two above the x-axis. So that's why we be divided like this one. So this one is x, this one is x. Okay. So the length is 2x, and then the width is y. Because we talk about the area, so the area is 2x, y. Okay, everyone? From here, we already know y equal 3 minus x squared, and then you just need to substitute from here 2x times 3 minus x squared. So it should be 6x minus 2x power 3. Because they talk about find the area of the largest, so you need to make the derivative. This first derivative is equal 0. The derivative of this one is 6 minus 6x squared equal 0. And then we can factorize about this one. 6 over 1 minus x squared is equal 0. So x equal 1 or x equal minus 1. Because the area or the length doesn't have x equal minus 1, so this one is cannot using. From here we get the x equal 1, so you can substitute to be here the area, or you can substitute to be y. So y equal 3 minus 1 squared, so it should be 2. So we get y equal 2 and x equal 1. And then you just need to substitute to be here. Ex equal 2xy, a1 equal 2 times 1 times 2, so this will be 4. So that this the largest area of the rectangle is 4, everyone. X equal half. When we get x equal half, you can make to the second derivative to implies that the value, the minimum or the maximum value. But actually this one is correct if you just need to continue to the y. So we need to continue to the y equal half plus 2. So y equal 5 over 2. So the coordinate is half, comma 5 over 2. So this one is the point, the closest point to the 1, 2. So that's it for today. Find the point on the line y equal x plus 2 that is the closest to the point 1, 2. Okay, so let x and let x comma y be a point on y equal x plus 2 such that the distance d between x, y and 1, 2. So you already learned in the last meeting about how to find the distance. The distance is square root of x1 minus x2 square plus y1 minus y2 square, and then we just need to substitute this one, we will get this, and then we need to change y to be x plus 2, and then when we substitute, we can cancel this square. Okay, the 2. So because we want to get the point, so let this one to be this square to make it easier to solve this problem. So it will be like 2x squared, this one 2x squared minus 2x plus 1. Okay, do you get it, everyone? Yeah. And then you need to first derivative about this one. The first derivative about this one is 4x minus 2. Because this should be equal 0. So thank you for learn with me today, everyone. I hope you enjoy my video, and then please learn more deep about optimization problem, because it's have a lot of the question to using the optimization problem. So thank you for today. Assalamualaikum warahmatullahi wabarakatuh.